Okay, so welcome to lecture once again, guys. Now in this lecture, I'll be talking about OOPS programming concept, object-oriented programming concept inside Python. Now, so why OOPS is important? So obviously OOPS is going to give a structure to my entire code base. It is going to increase a reusability of my code. Anyone today, tomorrow, or maybe day after tomorrow, so would like to change something inside my code. If they would like to add some sort of a feature, they will be able to add it in a easiest possible way. This is where OOPS concept comes into a picture. So where we divide each and everything in a terms of classes and object. Now inside this OOPS programming concept, there are multiple things which comes in between. So there is something called as class, there is something called as object, encapsulation, inheritance, abstraction, many more things, right? Many more things will come in between, and one by one, we are going to talk about all of these things. So let's get started, and I believe my screen is visible to all of us. Now, in a very first place, let's try to understand that what is a class and what is an object. Because this is a very first thing that all of you are going to encounter while talking about OOPS programming concept. So what is class, by the way, and how do we create a class? That is something which is very, very important and which we are supposed to understand. So see, a class is nothing but a blueprint, a sketch, a kind of a diagram, you can say, or technically it's a blueprint of anything and everything that you are going to develop or you are going to deliver. For example, if I'm going to write I is equals to 10, right? So Python will be able to understand that, okay, so this variable, right, that I have created, basically it's a integer variable. And then with respect to this variable, I can try to bring in, or I can try to call, right, with this respect to this variable. So I can try to bring in, or I will be able to call any related method or anything which is associated with it, right? Anything which is associated with it. So by default, Python program is able to understand that this is something which is a variable of a integer class. Similarly, if I'm going to create a string s is equal to sudh, same thing is going to happen, right? Same thing is going to happen, and it will be able to understand that, okay, so this belongs to a string class. So it belongs to a string class, and all the associated method it will be able to list down. So whatever method someone has written for this string class, so you will be able to find out each and everything, right? And many special method as well you will be able to find out over here with respect to a string. So everything and anything which has been implemented inside a Python, so obviously it belongs from some of the classes, and you just try to create an object, you just try to create a variable. So objects are nothing but a class variable, right? So you are just trying to create a variable, and automatically Python is able to understand that, okay, this is the type of this variable, and let's try to assign this particular feature to this one. This is something which happens inside the Python. That's completely fine. Okay. So how I will be able to create my own class, how I will be able to declare my own variable, which is technically an object, we will try to understand all of these things inside this lecture. So if you have to create a class inside a Python, so you can try to use a keyword called as class, and then you can try to write your class name called as test. Let's suppose you can try to give your name, my name as well. That's completely fine. So here I'm going to create a class called as test, and then I don't want to define anything inside this class. So what I can do is maybe I can try to leave it as it is. But if I'm going to execute it, it is going to give me an error, right? It is going to give me an error because it is expecting something inside this class if I have created a class. So what I will do is over there is that I can write a pass over here. We have already discussed about a pass keyword, right? So whenever we don't want any kind of implementation, so we can try to write a pass keyword and it will be passed. Very simple, right? It will be passed over here in this particular manner. Now, so when we say that we are not writing over here inside the class, right? So what is things that we can write? That's another question, right? So what is the thing? What is something that we can try to create inside a class? So we can try to create anything and everything that we want inside a class. For example, so let's suppose if I'm trying to create a class called as course, right? So we are selling courses. So obviously we can try to create a class called as course over here. And then we can try to define a function inside this class, right? So maybe I can try to define a function called as course details over here. And then inside this, I can try to print that this will give you a course details. Yeah, details. So now I have created a function inside a class, right? I have created a function inside a class, and I'm trying to write something inside this function. Now, is it going to work, right? Is it going to work? Let's see. So whether it is going to work or not. So here I have created a class, and inside that there is a function which I have declared, and I have written something inside this function as well. Now here, so if I'm going to create a class variable, so how I can create a class variable? So I can create a class variable by writing any variable name just like this, right? Just for the string and just for the integer that we have written. So by writing any variable name, and then we can try to call a course over here. So if we are going to call a course over here, it will be able to create a class variable. So C is what? C is basically a variable of course class. Yeah, C is basically technically a variable of a course class. Now execute. Now here, so if I would like to access C dot course detail, will I be able to access it? No, I will not be able to access this one. There is a very simple reason for that. So here I have created a function, as you can see, and inside this function, everything looks fine. So there is nothing wrong with this particular function, but the problem is that if I'm trying to create some function inside a class, so I have to attach this function, or I have to refer this function to this particular class, so that via an object I can try to attach this particular function, and I will be able to access it. Yeah. So how I can do that? So here you have to write a self keyword, and with the help of self keyword, this function, a very first parameter that you are going to define. So this for very first argument or very first parameter is going to attach your entire function to a course class. Simple, right? So this self is going to attach this entire function to a course class. Now, if I'm going to execute, you will be able to get, or you will be able to fetch this particular function, right? This particular function out of this course class. Now, so this is a class variable, right? This is a class variable. Now, this variable, right? This variable is called as object. This is called as object. So C is technically a class variable, or in other word, you can say that this is the object that I'm talking about. Very simple, right? This is the object that I'm talking about over here. And with the help of this object, you will be able to access anything and everything which is available inside the class. Not everything, but yeah. So as we will progress, as we will move, we'll try to understand more and more about it. Yeah. So this is not just one single variable you will be able to create. You will be able to create as many variable of this class as possible. So let's suppose C1 is a new variable I have created, and then C1 is trying to fetch a course detail. So yeah, I'm able to do that, right? Maybe C2 is something which I'm going to create as a class variable. So C2 is basically a course class variable. And then C2 is also trying to fetch basically a course detail. So yeah, it is able to fetch. Now here C1, C2 and C, all three of it is able to call this course detail. Now, so this variable C or C1 or C2, when it is trying to call this course detail function, or you can say method, right? Class method. So whenever it is trying to call this particular class method, so it is trying to call a separate instances. So this is different, and this is different. So this one is attached with this C variable. This one is attached with a C1 variable, and this one is attached with technically a C2 variable. So both are basically a different instances. So in other words, this class variable is called as object, as otherwise it's called as even a class instances. So all of these are basically calling a different instances of this same method which I have defined. And this is where you will be able to understand that I'm trying to increase our reusability. Reusability means I can try to create thousands of variables, means I have written this function only one time, and anyone and everyone is able to call it. Anyone and everyone will be able to use it as many times as possible in their own way, with their own variable, right? In their own way, with their own variables. So that's a beauty of the classes and object that we are talking about. For example, same goes with this string. So anyone and everyone can create a string, right? And millions of string you can try to create. There is no restriction on that. Similarly, so on this one, there is no restriction. One thing you have to make sure that whatever you are trying to declare inside, like let's suppose I'm trying to declare a function inside the class. So it should be attached with the class. So with the help of this parameter, a very first parameter, I'm trying to attach with the class. Now you can ask me a question that is self is a predefined keyword, because you will see self everywhere. I would say no. For example, so I'm going to copy the same one, and here, so instead of self, I'm going to write my name. Yeah, I'm going to write my name. And now if I'm going to create a C3 variable, C3 is basically a course class variable, right? And then C3 dot course detail, if I'll try to fetch, I'm able to do that, right? So this is not a keyword. It's just a first parameter which will be treated as a reference variable, or you can say it's a instance variable, so that it will be able to attach this function to the class, so that whenever you are going to call this particular function via any object, right? Whenever you will try to call this function via any object, it will be able to search inside the class that, okay, fine, so there is something which has been attached. If you're not doing it, it will not be able to find out. It will not be able to see the attachment over there. So now, so let's try to understand our next step. So let's suppose if I have to pass any kind of argument inside the function. So how I will be able to pass, for example, so if I have to pass maybe a course, a name over here, if I have to pass maybe a course mentor over here. So yes, in this way, just like a simple normal function, you will be able to pass anything and everything that you want. Anything and everything means anything and everything literally you want, you will be able to pass it over here. Only the first parameter will be treated as a reference variable. That's it, right? This is the only thing which will be treated, as you can see over here. So is basically self@course. So basically it is referring to the course class, and it is trying to attach this one so that any of my object or any of my variable or any of my instances will be able to access it in a easiest possible manner. Okay, fine. So here I have mentioned this course name and a course mentor. So now it will be looking for these two things whenever I'm going to call this particular function. So you have to provide a course name. So maybe I can try to provide a Python over here, and then you can try to provide a mentor name. So maybe I can try to provide SUDH over here. And yeah, so now it's working, right? Now it is able to print whatever I have written. So maybe if I would like to print like a course name and a course mentor, I can print that as well. So maybe formatted a string, and inside this I can try to call course name, and then I can try to call a course mentor, and yeah, so Python and Stanshu, I'm able to get it, right? I'm able to get it, as simple as that. Now, so this is fine. Now let's suppose if I have to pass some sort of a data when I'm trying to create an object. If I have to pass some sort of a data when I'm trying to create an object, for example, so if I do I is equals to 10, so obviously I is equal to 10 when I do, so I'm trying to create this variable I, and I'm trying to pass some sort of a value for it, right? I'm trying to pass some sort of a value for it. So similarly, so when I'm trying to create this class variable C3 or C2 or whatever, so whenever I'm trying to create this class variable, so if I have to pass some sort of a data, how I will be able to pass some sort of a data inside a class? Let's try to understand that part. So to do that, let's suppose I'm going to create a course class once again. So class course, and then inside this object-oriented programming language, Python, there is a provision of a special method. So you can try to use some of the special method which has already been designed for a certain purposes. Now, one of those special method is basically underscore, double underscore, right? Underscore, init, So this is the method you can try to use if you would like to pass some sort of a data at the time of creating an object. Very simple, right? At the time of creating an object, at the time of creating a class variable, if I have to pass some sort of a data, I can try to use init if it is required, right? If it is required. And just like any other function, so obviously I have to give a self. Self is just a convention that we try to give. Otherwise, you can try to give your name, my name. That's completely fine. So here def init I have written, right? Def init I have written over here, and then self. Now I would like to pass some sort of a data over here. So maybe I can try to pass a name and then a mentor when I'm going to create a class object. So how this name and mentor will be passed, and it will be passed towards a class. So to do that, what we have to do is we have to write in this way. So self dot name is equals to name, and self dot mentor is equals to mentor. Simple, right? So let's suppose I have written in this particular manner. Now if I'm going to execute it, now if I'm going to create C is equals to course, and I'm not passing anything. Now let's execute, see what has happened. So here I have given two parameter, name and mentor, which it will be looking for while creating an object. So here you will be able to find out that course init missing two required position argument, name and mentor. So it is looking for a value of name and mentor while creating a class variable, just like this one, right? Just like this one. So it is looking for a name and mentor. So here name of the course I can try to provide is Python and mentor is equals to SUDH. Now it will not complain. So if I have passed it, so how it will be passed towards a class? Let's try to understand that particular part. So here, whenever you are trying to say that Python and Sudhanshu, right? Python and Sudhanshu. So it is going from here to here, right? It will go here to here. Then from here, it is coming here. So this one is going here. And from here, it is coming over here. And then it will try to assign a variable value name. Self.name is equals to name. Self.mentor is equals to mentor. So in this way, it is attaching towards a class. So anyone and everyone will be able to understand that, okay, so this particular name, this particular mentor basically belongs to this particular instance or this particular variable of the class. This is how it will be able to understand. So the variable of the class is C, and C is having two values. So one is name and one is a mentor. C is having two values. One is a name and one is a mentor, which is having technically this value only for C, right? For some other object, so obviously I can try to provide some different name and some different mentor over there. Now, so here, so if I have to access name and mentor, how I will be able to access? So simply I can write C dot name, and I will be able to access a name, Python course name, and C dot means variable dot mentor, and I will be able to access a mentor name. Yeah, I will be able to access the mentor name. Now you can ask me a question once again that is this name and this name should be same? Is this mentor and this mentor should be same? No, not at all, right? Not at all. So for example, if I'm trying to change this one, name 1, and if I'm going to change this one as a mentor 1, now if I'll try to execute till this point, it will work. Now C.name, it is giving me an error. It is telling me that course object has no attribute, means course variable C has no attribute called as name. So basically this is the part which will be attached to, right? Attached to a object and eventually to a class, because object belongs to a class. So this part will be attached. This part is coming from where? So this part is coming from here. That's the reason. So I have drawn that entire flow, that this is how it is going to move. So Python will come here, from here it will be assigned, and this is the actual variable which your class will be able to understand with respect to a particular object. Again, this is the variable your class will be able to understand with respect to a particular object. Very simple, right? Very simple. So here, so I have written this entire thing. Let's suppose if I'm now calling name 1, I will be able to get it. If I'm calling mentor 1, I will be able to get it. So don't get confused. Generally, I have seen that people get confused, especially a beginner. They think that this name and this name is same, but technically it's not the same at all. Yeah, it's not the same at all. Okay, so here we are able to create this class course. Now, so if I have to use this variable inside a class, yeah, if I have to use this variable inside the class, how I can try to use it? So for example, if I'm going to write a method called as display, display. So obviously I have to write self as a first parameter so that it can attach to the class. And then if I have to print the name and the mentor. So within the class, right? Outside the class, if you have to access, you will be able to access it with the help of what? With the help of class variable, means object, right? Class variable, which is nothing but object or instances. So with the help of instance, you can try to access it outside the class. But within the class, if you have to access it, you have to access it in this way. Self.name1, you will try to access, and then basically self.mentor1, you will be able to access. So within the class, if you have to access any of its variable, then you have to attach, or you have to write basically or instance variable, I would say, right? Because going forward, I'm going to introduce one more thing, which is a class global variable. But yeah, so as of now, you can understand in this way that instance variable means whatever variable that you are trying to pass at the time of creation of a class variable, technically an object. So I'll keep on saying this class variable, but yeah, it's technically an object. I keep on saying this class variable, because people will be able to relate more and more. When I say object, people get confused. But yeah, it's not different at all, right? Just a just a variable that we used to create for anything and everything that we have done so far. For example, list variable, set variable, tuple variable, dictionary variable, integer variable, float variable, or maybe a complex number variable, boolean variable. It's same. So here, if I have to access some of the variable within the class or within the class method, so I can try to use a self, and with the help of self, I will be able to access it. Now here, so I'm going to create a class object C1, and C1 is basically a course object. So I have to provide a name of the course. So maybe a data CINC data science. Over here, I can try to provide mentor is equals to Sudh. And then C1 dot mentor 1, I can try to access. C1 dot name 1, I can try to access, as well as C1 dot display. Display is a function, right? Display is the function. So I'm not passing any kind of a parameter over here. It is just trying to print what? Name and mentor. So here I will be able to publish, as simple as that. Yeah, I will be able to display in this particular manner. So hope guys, all of you are able to understand the class and object concept. All of you are able to see that how to create a class, how to create an object, how to create a class where while creating an object, it will be looking for the data with the help of init. So I will be using this entire things again and again and again. Plus I have given you a lot of assignment questions. So please try to complete the assignment question. That will give you a complete robust idea, and it will give you a complete hands-on, which is very much important, right? So it is important than even going through a lectures, I would say. So because once you are able to do it on your own, believe me, you will be able to understand, and no one will be able to stop you today, tomorrow, or even in future. So with that, guys, thank you so much, and see you again in my next lecture, everyone. Okay, so welcome to lecture, everyone. Now in this lecture, guys, I'm going to talk about some of the special method which is available inside OOPS programming concept of the Python. So let's try to understand that part. So I believe my screen is visible to all of you guys, and let's try to explore what are the special method which is available inside a Python. So here, let's suppose I'm going to create a class. Let's suppose I'm going to create a class called as course over here. COURSE, course over here. And here, so whenever we have to pass a data while creating an object, so we try to do what? So we try to basically use init, right? Init in it basically. So init underscore underscore. So a double underscore before, double underscore after. So any method inside a Python, so which is going to start with a double underscore and end with the double underscore, it's called as special method, and it's an inbuilt one. It's already available. You don't have to create it. You don't just have to use it for a specific purpose. So for example, while creating an object or variable of the course class, if I have to pass maybe a title, and if I have to pass a mentor, so yeah, so with the help of this self.title, a title of the course, so is equals to title, and here self dot mentor is equals to mentor. So now with the help of this init method, I will be able to pass this title and a mentor. So whenever I'm going to like create an object for the courses. So for example, if I'm going to create an object for the course, 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 and yeah, so if I'm going to execute it, so it will be looking for a title and a mentor. So if I'm not going to pass title and mentor, if I'm not going to pass a title or mentor, so it is going to give me some sort of a complaint that missing two required positional argument, title and mentor. Now, so this is special method in it, which is asking me to pass a title and mentor, is called as constructor basically. So this is called as what? So it's called as constructor. So here it's behaving as a constructor. This entire things, this init things is behaving as a constructor. So constructor is nothing but a kind of a special method which is going to ask me for a data, as you can see over here. So while creating an object for a particular class, for any classes that we are going to perform. Now, so if I'm going to pass the title and mentor, so let's suppose if I'm going to pass maybe Python over here, and we are going to pass basically SUDH over here. So obviously it will be like it should not complain, right? So if I'm going to pass it, it should not complain at any point of a time. Name course is not defined, execute once again, and yeah, so it is not going to complain at all. So here complaint is closed, and I can try to call this title and I will be able to call a mentor, right? I will be able to call the title, I will be able to call the mentor, as simple as that. So this is one of the special method that we are going to use frequently. Now, what are the other special method which we are going to use it frequently? Let's try to understand. So I'm going to take the same example, and here, so let's suppose I have created an object C is equals to, right, C is equals to course, right, course variable I have created, and I'm going to pass maybe a Python, and mentor is SUDH I'm going to pass. That's completely fine. Now, if I'm going to do a print operation of the object, if I'm going to print of the object, so it is going to print something in a hexadecimal. It is not going to print any kind of a meaningful information. It is going to print something in a hexadecimal. But whenever we are going to call an object, right? So whenever we are going to print this object in this way, so I would like to print something meaningful, just like a meaningful information, right? So I would like to print some sort of a meaningful information. So how I can do that, and how I will be able to print a meaningful information. To do that, so there is a inbuilt special function which is given to you underscore underscore str underscore underscore, right? Now, so what it does, by the way, so this is going to help you out in terms of printing something meaningful. For example, so if I'm going to print my name is Sudhanshu, right? So now if you are going to print your object, so it doesn't matter how many objects you are going to create, how many variable you are going to create. Now, if you are going to print your object, you will be able to see something meaningful. For example, I have created I is equals to 10, right? I is equals to 10 if I'm going to create. I is equals to 10 if I'm going to create. And then if I'm going to like do print I, so obviously it is going to give me like a 10 over here, right? It is going to give me a 10 over here. In the similar manner, so if I'm trying to print maybe a object, right, object C, it should give me something meaningful, right? Maybe it should give me a title and a mentor. I can do that as well. So this method is available inside the class, and we know that inside a class, if we have to access something, right, so I can try to use self, right? So self dot title, so I will be able to access title, and then self dot mentor, I will be able to access mentor inside a class itself. So yeah, now it is going to print my name is Anshu, and then Python, which is title, and then which is a mentor. As simple as that. So str is a inbuilt function, a inbuilt special function. As we can see, there is a double underscore before and there is a double underscore after. So str is a special function which you will be able to find out inside a Python, which is been used to print something meaningful while printing an object. As simple as that. Yeah, as simple as that. Now, so there is another special function you all will be able to find out, and which is called as equal. So let me show you that part. Let me write down that function in the same one, right? So here, let me there is a function called as equal function. So let's suppose I have written def underscore underscore eq, right? Eq. So this function is already available. Yeah. So eq, and here I'm trying to write that return. So return what? So basically return self. Yeah. So return what? So self dot title is equals to, right, value dot title. So TITLE value dot title. So return something. This is equal to, yeah, self dot title is equal to value dot title. So self dot title is coming from where? Here, right? So it is trying to just check. So value dot title. So it is just trying to check some information, and based on that, it is going to give you some sort of a return. Now, what it is going to check? Let me show you that part as well. So let's suppose I'm going to create a variable of this course class, right? So CO1, course 1 basically is a variable of the course class, and here I'm going to pass Python, and I'm going to pass basically mentor. Yeah, I'm going to pass basically a mentor, and then we have a CO2, and I am going to again call this CO2 is an object, and here, so I'm going to call basically Python, and then I am going to call a mentor. Yeah. Now, so if I'm going to check that CO1 is equal to CO2, Now it is telling me true, right? Why it is telling me true, by the way? Let's try to understand that particular part. So here, right? So here we have used this special method called as equal. Now it is always going to check that whether two objects are equal or not. Means, so the object which is coming from one place, so let's suppose the object that I am trying to pass in one of the objects, right? So one of the like a value which I am trying to pass is equal to other values or not. Yeah, is equal to other value or not. This is something that we will try to check. Means equal to something coming from other objects is equal or not. So here, as you can see, that Python and Python, right? I'm just trying to check title, right? I'm not checking this mentor name, by the way. So I'm just trying to check basically a title over here. So based on that, it is trying to give me that, okay, both are equal. Now if I'm going to make Python 1, yeah, so one is a Python 1 and another one is a Python. So now it became false. Now it's not equal. It is trying to perform this operation. So whenever we are trying to do a comparison between the object, we can try to invoke a equal. And with the help of that, so we will be able to do an object comparison at any point of a time. Now, so there is another special function I would like to talk about, and that special function is basically called as length function. As name suggests, so length will try to give me some sort of a length itself. So here we can try to call a length function, and then we can try to return self.title. Let's suppose self.title. So for this one, it is going to return the length. This is what I'm trying to write, as simple as that. So here what we can do, so we can try to create a course, and here so we have to pass a title. So we can try to pass a title, maybe like Python, and then we can try to pass data, and then we can try to pass maybe big data, then we can try to pass data science, right? So now I'm trying to pass a title as a list, as you can see. Yeah, I can try to pass title as a list. I can try to pass title as a string. I can try to pass title as a integer. Doesn't matter at all for me, right? And then I'm going to pass a mentor as SUDH. That's completely fine. Now, so if I'll go and check that what is a length of a dot title, it is telling me that length of a dot title is what? So length of a dot title is equals to 4. Yeah. Now, if I'm going to ask that what is the length of a dot mentor, so a dot mentor is equals to basically 4 over here, right? SUDH in SHU, if I'm going to write. So a dot mentor is now, it became 9 over here. So now this length function, so in general, it is going to help you out in terms of finding out or in terms of giving you a length. Yeah, length of a particular object at any point of a time. So let's suppose if I would like to print maybe a dot title, TITLE, a dot title. So yeah, a dot title is basically this. And what is a length of a dot title? So length of a dot title is equals to this much, and mentor is 9. So now this length function is helping me out in terms of finding out the length of this title. Okay, so now you will say that it's working with the title, and if I'm going to perform this operation, so for example, if I'm going to do a dot mentor, it is going to work even for that. Let me execute it. So mentor is equals to SUDH and SHU. Yeah. So you will say that it is going to work for me even for a mentor and even for title. So why we are using a length? Because I haven't used a mentor, but still it's working. So here, see this entire function that we are trying to use, which is a special function. So we are trying to use it so that we will be able to invoke this special function property directly on a object. Yeah, directly on a object. Object means a, the class variable. So here, if I'm going to call a length on a, it is not going to work for me. So length on a, if I'm going to call, it is not going to work for me. So it is not able to find out the length of this A. Yeah, for title, for mentor, it is working, but it is working for title and it is working for mentor as well. Means whatever I have kept inside the length, it is not having any kind of a meaning, right? So here what we can do is that maybe to form a meaning, because it should work on an object, it should work on a whole object, and our object is taking title and mentor. So we can try to like use it in this way, that length of this self dot title plus it should give me, or it should return me, length of basically self dot mentor. Yeah, self dot mentor. Now if I'm going to execute, see, it is trying to understand, it is able to find out a length of both title and mentor, and total length is equals to 3. So from list it is able to get 4, and from my name it is able to get 9 is equal to length. 9 plus 4 is equals to 13, and eventually we are able to call it on a object, directly on a object. So now this is a meaningful information for this length, so that we will be able to find out the total length of the object that you are trying to use it. As simple as that. Now, so the next part is basically, next one is basically a delete. Next special function I'm going to discuss is called as delete. So here, if I'm going to call def underscore underscore del del underscore underscore, and here self, right? Here self. Now print, I will delete the object. Yeah, so this delete function is going to help me out in terms of deleting the object. For example, if I'm going to create A, which is nothing but object of this course class, and here, so I'm going to pass a title. Title is equals to, let's suppose, Python, and mentor, so mentor is equals to SUDHNSSU. Now if I am going to call A dot title, I will be able to call it. That's completely fine. But let's suppose if I have to do a garbage collection, if I have to do a delete the object permanently, so delete and then A. Now if I'm going to call A, there is no A which has been defined. So this delete A, I'm able to invoke, means I'm able to invoke delete on this object directly, right? Delete I'm able to invoke on an object directly just because of this one. Just because of this one, I'm able to invoke it and I'm able to use it. So hope all of you are able to understand that how this delete is actually working and how we are able to use this delete. What is the actual use case of the delete? Now there is a last but not the least, I would say, and a special function which I would like to discuss with all of you. There are again so many other functions which is already available, but yeah, this is the last which I would like to discuss with all of you. So there is a special function called as call. Yeah. So what it does, so basically it is going to allow your object to be treated as a function. How? Let me show you. So CALL call underscore underscore, and here, so I'm going to call self. Now, so what it will do is that it is going to allow to be called as a object, like I said. Yeah. So here I'm going to return maybe like a formatted string, and I'm going to return basically self dot title, and then I'm going to return like self dot mentor. Yeah, I'm going to return this. Now let's suppose I'm going to create an object A, and A is our object of the course, course, and here, so I'm trying to pass maybe a title. So title is basically Python. Sorry. So title is basically Python, and then I have mentor. Mentor is equals to SUDH. Yeah. So this is an object which I'm trying to create. That's fine. So A dot, and I will be able to call mentor. A dot titles, I will be able to call the title. That's completely fine. Now, so let's suppose I would like to call A, but I would like to treat A basically as a function. So will I be able to use it? Will I be able to call it? Let's try to understand. So A as a function. So A as a function. Yeah, I can try to do that, right? So see, I'm able to call A. A is my object, right? A is my object, and I'm able to call A as a function, as you can see. A bracket bracket. And it is trying to print what? So whatever I have written inside the call. That okay, so whenever someone is going to call A, try to return this one. So I'm able to call A as a function, and I'm able to do so because of what? Because of basically this particular special function which I'm trying to call. So every special function, like I said, so every special function is been given to you to empower your object at the end of the day. So in one way or other way, so it is at least going to empower your object. It is going to help you out in terms of empowering your object. So any special function that you can talk about. So these are the special function, guys, that you should know. But apart from that, you will be able to explore now other special function as well, because it's very easy to explore all the other special function. The reason is very simple. For a special function, just a one-liner definition, and then it's work on an object. This is something that you should know. And again, no need to remember any of these information. It's completely fine. Once you are going to write a couple of lines of code, you all will be able to understand automatically. So with this, guys, thank you so much. Take care and see you again in my next lecture, everyone. Okay, everyone. So welcome to lecture once again. Now in this lecture, guys, I'll be talking about an important concept called as inheritance. And there are a couple of other concepts which exist around inheritance. I'll be talking about that as well. So let me share my screen and let me talk about inheritance in a very first place. So guys, inheritance is, I just go after the name. So you will be able to understand that something we are trying to get, something we are trying to gain from someone else. That is something called as inheritance, right? So for example, we as a human being, so we all try to, or we all tend to, get some sort of a feature or some sort of a, special things from our ancestors, maybe from our uncle, aunt, or maybe from our parents, father, mother, or from someone. So we try to inherit some of the things, maybe the way they speak, maybe the way they laugh, maybe their hairstyle, maybe their color, and many more things, right? So we try to inherit something from our parents, from our ancestors, or from someone, right? We always do that. Now, in the similar manner, in a Python programming, you will be able to write a code, so where you will be able to inherit something from someone else. And in this way, you will be able to increase a reusability of the code even more. So how? Let's try to understand. So here, let's suppose if I'm going to create a class, right? If I'm going to create a class called as mentor class, yeah? And inside this mentor class, let's suppose I'm going to define a constructor, indent underscore underscore, which is going to ask for the data at the time of object creation. So self dot name. So let's suppose this is the constructor I'm going to create, and self dot name is equals to name. Yeah. So this is basically a constructor, and then I can try to say that def dot show, and here basically I can try to say that print what? So print formatted string, and print basically mentor what? So print basically self dot name. Yeah. So this is a very basic mentor class I have already created, and inside that, so I have one constructor, so which will ask for me for the data at the time of creation of object, and there is a function which I have created, class function I have created. Okay. Now, so once this part will be done, so once I'm able to do that, now let's suppose I don't want to use this particular class directly. So what I want is that I wanted to create a class called as Euron mentor. Yeah, Euron mentor. And inside this class, I would like to call this entire feature, this entire property. How I will be able to do that? So maybe I can try to write mentor over here, mentor, and then pass, right? Pass. Now what I have done? So I have basically inherited each and everything from a mentor class to a Euron mentor. This is what I have done just by calling a mentor over here. Everything which mentor have, so everything will be available inside a Euron mentor automatically. For example, I can show you that part. So let's suppose I'm going to create an object of Euron mentor. I'm not creating an object of mentor, by the way. I'm trying to create an object of Euron mentor. Now, if I'm going to execute it, it is giving me a complaint saying that missing one required positional argument, name. See, I have created an object of what? Euron mentor, this one, right? And I have not defined any kind of a things like a name or something. Yeah. But why it is still trying to complain? It is still trying to complain because it is trying to inherit, right? It is trying to inherit everything which is available inside a mentor class, inside a Euron mentor. And that's the only reason, right? That's the only reason. So that's the only reason it is trying to give me a complaint that you have to give me this value. If you're not giving me this value, I'm not going to execute it. As simple as that. So here, right? So here I have to give a name. So maybe I can try to give a name SUDH. And then if I'm going to call, right? Then if I'm going to call EU dot name, I'm able to get it. See, so without even writing any single function inside a Euron mentor, I'm able to use this constructor. I have to pass the data. Plus, I will be able to call this show with the help of this EU itself. Show with the help of EU itself. So mentors Danshu. So I'm able to call it. I'm able to call this function, right? And whatever is available inside this function, I'm able to print it. But via what? Via Euron mentor. I'm not using a mentor at all. So this is called as inheritance. So where I have inherited everything which was available inside a mentor, right? So I am able to inherit everything which was available inside a mentor, inside a Euron mentor, and successfully I am able to even use it. Very simple, right? Very simple. So this is the beauty, I would say, guys. This is the beauty of this inheritance. Yeah, this is the beauty of the inheritance. Now I'm going to copy the same class over here, and then I'm going to copy the same Euron mentor. So same Euron mentor I'm going to copy. Now here, so I have created the Euron mentor. So by default, when I've written this mentor over here, so by default it is trying to inherit all these things from this mentor class to this Euron mentor class, right? By default, this init is available, this show is available to the Euron mentor class. Now in Euron mentor class, apart from this, if I would like to create some of the function which is just specific to a Euron mentor class, I can do that. For example, so I'm going to create maybe a assign course kind of a function, self.course, and then a print, right? So print f of self.name, and then self.course. Yeah, self.course. Now, so here, right? So here what we are trying to do is that we are trying to create one special function inside a Euron mentor. Now this function will belongs to a Euron mentor itself, right? This function will belongs to a Euron mentor itself. And here, so what we are trying to do, so we are remove self.course because we are not attaching with the instances. So just keep it as a course. So here we are trying to assign one of the function which is specific to the Euron mentor. Now if I'm going to execute it and then Euron mentor, so Euron mentor, if I'm going to create an object for that Euron mentor, so obviously I have to pass a name. So let's suppose name is equal to Dhanshu. I have passed. Yeah. So EU dot. Now if I'm going to do, so it has three things. One is a assign course, one is a name, and one is a show. So name is basically a variable, assign course and show is basically a function which I have already attached, right? Function which I have already attached. Now if I'm going to call show is coming from where? Show is coming from its parent, mentor, right? So is coming from where? So is coming from the mentor. And if I'm going to write Euron dot assign courses, so assign course is coming from where? So assign course is coming from this Euron mentor itself. Now, so it is telling me that assign course takes one positional argument called as course. So, okay, try to pass that. So, one positional argument, and yeah, so whatever was there inside the assign course, I'm able to do that. I'm able to get it. So, what technically I'm trying to show you over here that you can try to inherit everything from your parent. So, this is my child class. So, I can try to write Euron mentor as a child class, and this is basically a parent class. Yeah, so it is trying to inherit everything, right? It is trying to inherit everything from the parent class to the child class, and inside my child class, so I can try to define whatever I want as per my need. That's completely fine. Yeah, that's completely fine. So now moving ahead with another example, right? So let's try to move ahead with the another example. So here what I can do is that I can try to create a small class, CLASS class called as mentor, let's suppose. And here I'm going to define one function for a mentor. So intro function, let's suppose, self. And here, so it is going to give a intro. So my name is Sudhanshu. Fine. So this is the mentor class, and this is just an intro function I have defined, which is going to print something. Okay, that's it. Now I'm going to define basically another class called as Euron mentor, let's suppose. And here inside this, I'm going to inherit mentor. Inherit mentor means this will be available inside Euron mentor. Yeah. So this will be available inside the Euron mentor. Now what I can do. So here, let's suppose I'm going to define intro again over here. So intro again over here. And here, so I'm going to say print, this is my new Euron mentor. Yeah, new Euron mentor. So see, I have done the inheritance. So obviously this function must be available here to a Euron mentor. But same function, right? So whatever function which I had inside my parent, so exactly same function what I have done. So same function I have rewritten even inside a child class, a class where I'm trying to inherit something which is already having the exact same thing. Now, if I'm going to create an object of this Euron mentor, right? If I'm going to create an object of this Euron mentor, if I'm going to call eu.intro, right? Which function is it going to execute? So it is going to execute a function from a child class, or it is going to execute a function from a parent class. I'm trying to create an object of child class, by the way. Yeah, I'm not creating an object of parent class. Forget about that. So I'm creating an object of a child class. So is it going to like, execute a child class, or it is going to execute a parent class? Let's execute it and show it. I think you all know the answer. So here, this is my new Euron mentor. So it is an object of a child class. So it is trying to execute everything from the child class, not from the parent class. So this is something called as overriding. So I have just overridden the function which I have inherited. Means I have just given my own definition. Name of the function is same. It's not changed, right? So name of the function is same. So I'm just trying to override the old one. This is what I'm trying to perform over here. That's it. Very simple one. This is something which I'm trying to perform in this place. Okay. That's great. So here, right? So okay. So here I'm trying to basically override. Okay, that's fine. But before, along with this override, what I want is that I would like to even execute something which is already available inside the parent class. Means I'm trying to execute this intro. So when I'm calling this one, right? So but inside this, I would like to call something which is already available inside the parent class also, right? I don't want to miss this particular part. So what I can do, I can try to call something called as super. Super is a inbuilt function which is available. So if you have to call something from your parent class, right, you can directly call it with the help of super if you are trying to do a inheritance. So super dot, and then if you are going to call intro, so it is going to execute, this line is going to execute what? So this line is going to execute super. Who is the super of Euron mentor? Mentor is a super, and there is an intro. So it is going to execute this first, and then it is going to execute this one. As simple as that. So now do this. So here, if I'm going to execute Euron.intro, so it is trying to execute first of all this super, which is available in my parents class. My name is Danshu. So I'm able to get that. And then it is trying to print something from the current one. So here I'm just trying to show you a super. So with the help of super, even though after overriding, right, even after overriding, so I have a way. So I have basically this super way. So with the help of this super function, I will be able to call anything from the parent class, and I will be able to execute it in a easiest possible manner. Okay, now let me show you another example of a super with respect to the constructor init method itself. And some people gets confused in general. So I think you all will be able to clarify your confusion. So class COURSE, class course I have created, and let's suppose inside this I'm creating a constructor, so which will ask for the data while creating an object. So init self, and then we have title title. Okay. Now self dot title is equals to title. Fine. Okay. So this is the init which I have written. Self dot title, and then I'm trying to write inside a init print function, let's suppose. So print what? So print basically self dot title. Yeah, print self dot title. So print this one. So whenever I'm going to call my init function, so it should like print this one. Okay, fine. Now so execute it. Now here, so let's try to create another class called as Euron course. Yeah, and it is going to inherit my course class. Let's suppose course class, it simply means that this property must be available with this one. Yeah, this entire property must be available with this one. This is what it means when I'm trying to do a inheritance. But here, so when I'm trying to create this child class, which is a Euron course, and I'm trying to inherit everything from the course class, so I just wanted to add a couple of more parameters. See here what will happen. So whenever I'm going to create an object of this Euron class, right, Euron course, I'm going to create, it is going to ask me for this title. Yeah, it is going to ask me for the title. The reason is very simple, that it is trying to do the inheritance, and its parent is trying to look for the title while creating an object. So obviously even it will look for the title while creating an object, right? While creating an object. That is something that we have already seen in the beginning itself. But I don't want to like, I just don't want to like take a title. I would like to take something else as well for a child class. So while creating an object, so just not title. So yeah, title it is going to take, that's completely fine. But apart from title, so I just want my object to take some other data as well, right? Some other data as well with respect to this Euron course while creating its object, its child class object, right? While doing this, not just a title. So how I can do that part? So maybe I can try to create my own init. So while I'm trying to say that I'm going to create my own init over here, title, so which should take a title. Yeah, which should take basically a title title, and which should take another variable called as mentor. Let's suppose it should take two things, not the title. So it should take title as well as it should take a mentor. So title it should take, right? Title it should take basically from this one. Yeah, and then mentor it should take here, because title anyhow like parent class is trying to use it. So self dot mentor is equals to mentor I have, let's suppose, defined. Yeah, self dot mentor is equal to mentor, let's suppose I have defined. Now I'm going to perform a print operation inside this init. So print basically formatted string, and here, so try to print basically self dot title, and try to print self dot mentor. Yeah, try to print self dot title and try to print basically self dot mentor over here. Okay, that's great. Now if I'm going to execute, and if I'm going to execute this object, right, now if I'm going to execute this object, so now it is asking me for two parameters, title and mentor. Yeah, it is asking me for two parameters basically, title and a mentor. Okay, so here if I'm going to pass my title, let's suppose I'm going to pass Python, and my mentor is basically SUDH if I'm going to pass. Now it has a different complaint. See, previously when I was not giving anything, right, when I was not giving anything, it was not complaining, right? It was complaining like, I give me title and mentor, and when I have given title and mentor both, now Euron course object has no attribute called as title. Euron course, and it's not a highlighted one, as you can see, right? It's not a highlighted one. So I'm trying to create an object of this Euron course, and previously it was having complaint for like a title and mentor. Now I have given that. Now it is complaining that it is having no attribute as a title, and this is not a highlighted one, as you can see in a Python code. So what is the issue, by the way? So see guys, here again I'm trying to perform a overriding operation, right? So I have overridden the init function. So now it is trying to behave, this object is trying to behave as per this init function. So whatever this init function is going to ask, it is going to take that one. So if I'm going to like, so now it is telling me that missing mentor, right? Missing mentor, by the way. So here the problem is that, let's suppose I'm going to remove this title. Yeah, I'm going to remove this title. So in Euron course has no order called a title. Okay, so now remove even this particular part. Remove title itself. Everything remove it. Now it's fine. Now it's fine because I have just overridden. Simple, right? I have just overridden the init. So now there is no relationship between this title and this mentor at all. Relationship is gone, basically, right? But no, that should not happen. So I was looking for a title as well as mentor. That was my requirement. So I was looking for a title from my parent class and then mentor from my Euron courses. That was my original requirement. Now, how I can fulfill that original requirement? So I think we already know the way. I have already told you, super. So let me show you with the help of that one. So here I'm going to create a title title, right? And I have to use a title from above. Like I have to use basically a title means init, right? So whatever variable which init was taking, I have to take that one. So here what I can do is I can call a super once again dot what? So dot init. So use a init of a super and then initialize what? Initialize title. So initialize title is, or you can write even in this way. So initialize title is equals to title. Yeah, means this title, right? This title I'm trying to initialize with this local title, which I'm going to pass eventually. So it is going to invoke what? It is going to invoke my parent class constructor. Yeah, it is going to invoke my parent class constructor. Now title value will be available, and if you would like to print the title value, so just try to like do self dot title and you will be able to print. Now via this approach, it's very simple. It looks like sometimes tricky when you will look into this for the very first time, but it's not at all tricky. Yeah, it's very, very simple. So here super init and title or title, and I'm able to print each and everything. Yeah. Now, so if I'm going to pass like a mentor and title, so let's suppose title, course title is Python. Now it's working fine. Now it's trying to call this Python. Now from where we are getting a Python? Print Python from this one. So it is trying to invoke what? It is trying to invoke basically this init as well. And it's trying to print. See, it is printing, right? And then it is trying to print this one, so which is coming from my child class. So in this way, I'm able to use a init which was available in my parent class. I'm able to pass a variable which was required by or data which was required by a parent class init class, and then I'm able to create a child class init where I'm able to pass something more, right, which is a requirement of a child class. So in this way, I will be able to perform again the inheritance, and here is the super method. So with the help of super, in a previous example, I have shown you something I can try to call from the parent anytime I want. And then again, so even like inbuilt function, I'm able to call it over here. Okay. So now let's try to understand a couple of more things with respect to the inheritance. So far we are able to do a good amount of inheritance. Now let's try to let me try to show you a multiple inheritance, right? Sorry, multi-label inheritance, and then I'll show you multiple inheritance. So here, let's suppose I'm going to create a class called as platform, F-O-R-M, platform. Yeah, class is platform. Def dot show. So this is going to print something. So def dot show print. This is my Euron platform. Yeah. Now there is another class I'm going to create, class, right? So I'm going to create basically a course, and course is trying to inherit platform. So obviously this show will be available, right? This show will be available. And here, so I'm going to create a function. So display course. So this is going to print basically print what? So this will give you a course details. Yeah. So see, there is a course class trying to inherit a platform class, PLATE, whatever is the like spelling, it's fine, leave it. So here this course class is going to inherit something from the platform class, right? So something it is going to inherit from the platform class. Something means this function. So this course class will be having two functions. One is its own function that I have already created, display underscore course, and one function is a show function. So if you are going to create an object of this course class, obviously it is going to show you both show as well as this one. Now I'm going to create another class, right? Another class called as DSA. Yeah, DSA. And here I'm going to inherit basically course and def intro. Print. This is my DSA course. Yeah. So now this DSA is calling this course. DSA is calling this course. Course is calling this platform. So and now course will be having access of two functions, show and display. Now DSA will be having an access of three functions. So one is a intro and two from the course. Course is having two access, right? This show and display courses. So here to just to prove that, right? So here object of DSA I'm going to create. So object of DSA I'm going to create. Now if I'm going to call the object dot, you will be able to find out that it is having an access of all three. One from the platform. See, in a DSA I'm not directly calling this platform. I'm calling courses and course is calling platform. So here you can say that this is my child. So this is maybe my child. This is my parent for DSA by the way, and this is my and this is my grandparent for a DSA. Simple, right? So child, parent and a grandparent. So in this way I'm trying to invoke this one. So obviously DSA will be having access of intro, display courses and so all these things. Now this is called as, right? This is called as multi-level inheritance, as simple as that. Yeah. So multi-level inheritance, we are trying to do it. So, okay, that's amazing. So here one by one, just try to call the show and I'm able to access this is the Euron platform, then ds dot display courses. So it will try to like call something from the courses and then ds dot basically intro. So it is going to give me the intro from the DSA class itself. Yeah, DSA class. So I can try to even call in this way and in a multiple hierarchical way and as simple as that. So whatever is available to its parents, it will be available to the child. It's as simple as that. Okay. Now, so I'm going to show you something different over here. So multi-label is completely fine. I'm going to show you a multiple. Multiple means, let's suppose I'm going to create a class design. Yeah, class design. And here, so I'm going to create a function called as UI. I'm going to create a function called as UI self. And then I'm going to do the print. So this is my system design. Okay, fine. So this is one of the class that I have created. Then I'm going to create a separate independent class, curriculum, let's suppose. And it is not going to inherit anyone. So again, it's an independent class. And here, so def syllabus self and print curriculum loaded. Yeah, curriculum loaded. Now, these are the two classes which I have created. Now, there is a third class I'm going to create, Euron system class. And here, so I'm going to call a design class as well as I'm going to call a curriculum class. Yeah, here I'm going to call the curriculum class and then I'm going to call pass. Fine, I'm going to call a pass over here. Now here, as you can see, this one single class is trying to inherit two classes, right? One single class is trying to inherit two classes. Now, if I'm going to create an object of this Euron class, Euron system, Euron system. Now, so what and all things are available? Both. Something from a design and something from the curriculum is available to me. So from a design, I have a UI method which is available, and from a curriculum, so I have a syllabus method which is available to me. So EU dot and then UI. So from both the class, from both of this class, I have something which is available inside my child classes, right? So I'm able to do a multiple inheritance over here. I'm able to inherit a multi-class. So this is called as multiple inheritance. Yeah, so this is called as technically a multiple inheritance. So successfully we are able to, like, inherit something from multiple classes inside one single child class. As simple as that. Okay. Now, so here, when I'm able to create an object, right? So when I'm able to create an object, so there is something called as MRO. Or I can call this Euron system dot MRO. Yeah. So here, this there is something called as MRO, method resolution order. Yeah. So basically, this MRO always try to tell you that whenever you are going to give a call, so whenever you are going to call an object of this class, Euron system, right? Euron system class. So MRO always tells you that what will be the priority, right? What will be the priority? Which one will be called first, and which one will be called second, and which one will be called technically third? That is something called as MRO, method resolution order, right? So here you can try to print MRO for any of this class. Any classes you can try to print MRO, by the way. Any class, not just for this class. For any class you can try to print the MRO in a easiest possible manner. Even the previous class that we have created, right? This class that we have created. So even for maybe a DSA class, I can go ahead and I can try to print basically dot MRO. Yeah, MRO. So now it says that which one will be given a first priority. So if I'm going to call an object of this class on which I'm trying to print MRO, right? So if I'm calling a DSA class, so first priority will be given to a DSA class itself. Second priority given to the course class, right? And third priority will be given to the platform class. So this is technically order it is trying to print. Similarly, so here you will be able to find out that it is trying to say that, okay, so first priority will be given to the Euron system class. Second priority will be given to the design class, and third priority will be given to the curriculum classes. So whenever you get confused, just try to print a MRO, and MRO is going to tell you that, okay, so this will be the order, or this will be the priority I will try to give in terms of inheriting some of the properties, right? So some of the properties from my parent class or maybe from a grandparent class. This is the use of a MRO, which is a inbuilt one, and with the class you can try to call your MRO. So with that, guys, hope all of you are able to understand a lot with respect to a inheritance, with respect to a super method, with respect to a MRO, multiple and a multi-label inheritance, and hope all of you are going to solve the assignment and all of you are going to use this entire concept. With that, thank you so much everyone. Take care and see you again in my next lecture. Okay, so welcome back to lecture once again, guys. Now in this lecture I'll be talking about instance method, class method and a static method. So what is this three things, and I'll try to give you explanation that what is called as instance method inside the OOPS programming concept, what is called as a class method. I think we already know about that, but still I'll try to give you a good explanation over here, and then what is called as a static method. So let's try to understand just by looking into the example. So here, let's suppose I'm going to create a class, and my class is basically a mentor class, and then I'm writing def in it, which is a constructor, by the way. So which is technically a constructor. So init is going to take the name of the mentor, for example. And here, so it is going to do self dot name, so that it can attach this name to my class instance. Yeah, name. Now here, so if I'm going to call def and then introducti1 introduction and one of the method, right, one of the method inside the class, so return formatted string, let's suppose, and here, so I am a mentor, and then it can invoke a self dot name on Euron. Yeah. Now, so here, as we can see that I have created one method. Yeah, I have created one method. Now this is what? So this is basically a instance method I can see. Yeah, so this is basically a instance method I can say. So why I'm calling this as a instance method? What is the meaning of the instance method? So first of all, what is the meaning of instance? I think we all know. We all have seen that multiple times, not just one or two times. So here, if I'm going to create a variable m of what? Mentor class, which is technically called as object and which is also called as instance, right? Instance. So here, if I'm going to pass a name sudh, so m dot if I'm going to call introduction, so obviously it is going to execute it, and it is going to execute it with this object or this instance or this variable data. Yeah. Now if I'm going to create maybe m1, and this is the another object. Now here, if I'm going to pass maybe something, this one, some random things, and if I'm going to pass m1 dot introduction, right, call m1 dot introduction, so it is going to execute it with a data passed by this instance. Yeah. So here, this entire function, right, this entire function is going to be attached with a different instances in its own way. Function is one, but yeah, so I'm just trying to attach it with a different objects. Technically, it's called as instance. So don't get confused. It's the same thing that we have been doing since a very long time. Yeah, it's the same thing, exact same thing that we have been doing. So nothing new for all of us. So this is called as instance method. Instance method means with every object you can try to associate it, and with the like a calling of the object, it is going to behave. It is going to behave in that particular manner. It's called as basically a instance method. Okay, that's great. That's completely fine. So it is going to behave as an instance method. Now, so what are the other method which is available? Yeah, what are the other method which is available? So let's try to understand that part as well. So here, let's suppose if I'm going to create maybe a new class. So let's suppose if I'm going to create a class called as course over here, and I'm going to define a variable over here, total total underscore course is equals to 0. So this is basically a class variable I have defined, not an instance. So I'm not associating this with the object. So this will be associated with the class, directly with the class it will be associated. Okay, fine. Now I'm going to define over here. So def underscore init underscore and then self comma title. Okay, so title is the variable it is going to ask for. Self dot title is equals to title, and here, right, self dot title. So obviously it is going to define a title, and every time when I'm going to call an object, right, so every time whenever I'm going to call an object, so it should do what? So it should basically call this init, because this is what it will do, right? So whenever I'm going to call the object, it will call the init, and every time it should count that how many object is been created, how many object has been created at the end of the day. So how it is going to count? So here, every time whenever I'm going to call init, means init will be called when I'm going to create the object. Yeah, and it should increase this counter. It should increase this counter. So how it will be able to increase this counter? First of all, how I can access this variable? So to access this variable, I have to call my course, right? Course class dot total course. So with the help of this class itself, I can access this one, because this is associated with what? Total course variable is associated with what? A course, right? And just try to increment it. So course dot total course plus 1. So here what I'm trying to say, that whenever I'm going to call init, right, whenever I'm going to create even a single object, it will do this, it will do this as well. So eventually at the end of the day, so if I'm going to do this, this is going to increment. Yeah, this is going to increment. Okay, that's great. Now, so let's try to create a function inside this class. So def get underscore total underscore course. Yeah. And here I'm not going to attach with a self because it will be like a notification for an object for an instance. So here I'm going to write a CLS, right? Here I'm going to write a CLS, and then it should return what? So CLS dot total course, CLS dot total course it is supposed to return. Now, so by doing this, I'm trying to say that this should be attached to the class. So this should be attached to the class, not to the instance, not to the object, by the way. Yeah, not to the object. So how this will be attached to the class? How anyone will get to know that this is the function, right? This is the function which is going to report directly to the class, not to the particular instance or not to the particular variable or object. So here you can try to decorate it with something called as class method. So now with the help of this decoration, this entire function became a method of the class. This is what it means. Yeah, this is what it means. So this particular function is now directly associated with the class method. Simple, right? So execute it. Yeah, execute it. Now let me show you the demo. So here, whenever I'm going to create an object of this course, so let's suppose I'm going to create an object of this course class. Object is CO, and I have to pass a title. So maybe I can try to pass Sudhanshu Kumar as a title. That's completely fine. Yeah, because that is not even objective. Objective is to show you the access of class method. So okay, execute it. One time I have executed, right? One time I have executed means this is something which I have passed here. So it must be available to this one, and yeah, so CO dot, if I'm going to call CO dot here title, so I will be able to get the title. So whatever title which I have passed, I will be able to get the title. Now, so if I have to, right, if I have to basically access this total course, how I will be able to access? So what is a total course which I have created? Means how many total course object which I have created, how I will be able to get an access? So here CO dot total course, if I'm trying to access, so yeah, with the help of this object, I'm able to access it. Now let's try to create CO1, another object of the course class, COURSE course class. Let's try to create it. And this time title is equals to data science I have given. Now, so CO1 dot total course, and this became 2. So I'm trying to access a total course even with the help of object. And yeah, class objects are able to access whatever is there inside the class. Yeah. But the ideal way is to access this one is simply by calling a class. So here course dot total course, and it's 2. Now why it is giving me 2, by the way? So because I have created object how many times? 2 times. 1 over here and 2 over here. So 2 object I have created. Even if I'm going to execute it again, so counter will increase, because every time I'm going to do this, right? Every time I'm going to do this, it simply means that I'm trying to create an object, right? Simply means that I'm trying to invoke this init, and inside this I have kept the counter. Now, so here get a total course. So how I will be able to get this class method? So CO dot get total course, if I'm going to call, it is going to give me 2. So with the help of object, I'm able to call it. Or the ideal way is to call the class and then get total course, and you will be able to access that. Yeah. So this is the method. This is the method by doing this. So this is the method. And as you can see over here, so convert a function to be a class method. A class method receive the class as an implicit first argument, just like instance method receive an instance. To declare the class method, use the idioms. So this one you have to use. Yeah. So it can be called either on a class or on an instance. The instance is ignored except for its class. If the class method is called for a derived class object is passed to an implicit first argument. So now, so this is basically a class method that I was talking about. So now we are able to create successfully a class method, and with the help of class, I will be able to call it. And even with the help of like an object, I will be able to call it. That's completely fine. But the ideal way is to call it via the class. As simple as that. Okay. Now, so class method is fine. Instance method is fine. Yeah, instance method is fine. Now, so class method will directly belongs to the class, and obviously if something is a part of class, so you will be able to call it even with the help of instances. Now here, I'm going to create another class called as, let's suppose, students, students, students. And here, so I'm going to create a function is underscore valid underscore email, right? Is valid email. And someone is going to pass an email. It is going to check whether it's valid or not. So return. So if there is a @ in email, and if there is a dot in email, yeah, so it will try to check basically, so whether these things are available or not. It will return true or false. This is the very simple function I have created, nothing much, so no need to talk about the logic over here. But yeah, this is the simple function which I have created over here. Now you will say that you have not written something called as self. You have not written even CLS, which can eventually help it out in terms of like creating this as a class method or instance method. So what kind of operation you are trying to showcase to me? So here I'm trying to show you basically a static method, right? A method that you don't want to attach to anything, to a class or to an object. So in that case, what you can do is you can try to call a static method over here, decorator. And when you are trying to declare any method as a static method, you don't need a self now. Yeah, you don't need a self now. So now you will not be able to see @self @class name. You will not be able to see that. So when you have declared something as a static method, so now it's a free method. Anyone can call just a class name dot, and then anyone can call basically is valid email, simple class name dot is valid email, and anyone will be able to like utilize this. So Euron dot one. So it's neither a class method, it's neither a instance method directly. It's a static method which I have created. So here you don't have to pass even a first parameter as a CLS or first parameter as a self. Simple. So this is something called a static method. So it's just like a simple normal method that we used to define. So that we have been defining so far. So in the similar manner, I have just created one of the function. Likewise, you can try to create hundreds of the function, right? And just decorate it with the static method so that anyone can call just class and then that method, and they will be able to use it in a simplest possible manner without even creating the object. Yeah, without even creating the instances. So with that, guys, thank you so much, everyone. Take care and see you again in my next lecture. Hope all of you are learning, and yeah, assignment is important. Please try to complete the assignment. Then only you will be able to learn things in a real way. Yeah, with that, thank you so much, everyone. Take care. Okay, so welcome back once again, guys. Now in this lecture, I'll be talking about encapsulation. So what is encapsulation? Let's try to understand it. So encapsulation, as its name suggests, that we are trying to wrap it up something inside the capsule. Means we are trying to hide something, because inside a capsule, you will not be able to see what is there inside the tablet, right? What someone is trying to put up inside the capsule. So in the similar manner, so this is where encapsulation comes to a picture, even with respect to the OOPS programming concept. So where we can try to hide some of the information, or we can try to put some sort of a restriction over here. How? Let me explain it to you. So here, so when we are trying to create a class, and let's suppose we are trying to create a class a student over here, student, student over here, and we are trying to write like a def init underscore init. Yeah. Now init, and let's suppose if I'm trying to pass some sort of a name. Yeah, I'm trying to pass some sort of a name. When I'm writing self dot name is equals to name. Yeah. Now anyone can create a object of this student class, and they can try to access this name variable. Yeah. So let's suppose if I'm trying to pass student name is equal to studh, so anyone can do that, and s dot name, and anyone can access it. Now this is called as public. This variable is basically a public variable, means without any kind of a restriction, anyone can access it. Simple. Yeah. Now, same thing I'm going to consider, same thing. And here, so I'm going to give one single underscore with this name, only one single underscore. Yeah. And now if I'm going to call S1, S1 is equals to student object, so student, it's object of a student where name is equals to studh. Yeah. So now S1 dot, if I have to access name, so you have to give this name as it is, underscore, and then you will be able to access it. Now you will say, okay, that's pretty much obvious because this was the variable name in case of this, and underscore name is a variable name in case of this. So what you are trying to tell, what you are trying to say over here. Now what I'm trying to say over here is that by convention inside a Python, there is a concept of public, protected, and a private variable or any method. Yeah. So it's a convention. It's a convention. Python thinks that everyone who is using a Python programming language are mature enough to treat or to give a due respect to a particular object, variable, or method, whatever you are going to create. So in case of Python, this is basically a protected variable if you are going to write one single underscore in front of variable name. So whenever you are going to call it, you should call it by giving a respect to its protection. Yeah, it's just a convention. You will be able to invoke it, you will be able to call it. There is no issue at all. But yeah, so you have to call it with a respect that, okay, fine, this is the protected variable. So whenever I'm going to call it, so I should give a due respect. I should not unnecessarily utilize it. Yeah. So this is basically called as a protected, a part of encapsulation. Now let's suppose if I'm going to call a exact same thing, and instead of one single underscore, I'm going to give double underscore. Yeah, I'm going to give double underscore. Now if I'm going to create S2 is basically an object of the student. I'm going to pass name studh. Now if I'm going to call S2 dot double underscore name, will I be able to access this name variable? Yeah. Will I be able to access this name variable? No. So it is telling me that student object has no attribute called as double underscore name. There is no such object which is available inside the student double underscore name. It's not even available, right? It's not even available over here. What is the reason, right? What is the reason? So first of all, if you are trying to append double underscore before, it simply means, as per Python, it's a convention. So as per Python, it simply means that it's a private variable. So this one is a private variable. In case of a Python, it's a private variable that we are talking about. Now, so when you are going to put a double underscore, you can't access it directly. Yeah, till single underscore means still protected, you will be able to call it. But with a double underscore, you will not be able to call it. Now, how you can call it? So Python has given you a provision called as name mangling. What is the meaning of a name mangling? So if you are going to attach a class name, underscore class name, and then underscore underscore variable name. So now in this way, you will be able to access this as well. So this approach is called as name mangling. Means we are trying to mangle the name. We are trying to change manipulate the name, and we are trying to append the class name, underscore class name before the variable name. And then we are able to access it if something is declared as a private. Simple, right? If something is declared as a private. Now, so if something is declared as a private, so this is how with the help of name mangling I can do that. Or else I can try to put up even a getter and setter, right? So maybe def and then get underscore name is my own custom function I can try to create. Yeah, the own custom function, and return what? So self dot underscore name, because inside a class you can access it with the help of underscore name. You don't have to do a name mangling, right? Now outside the class, if someone is trying to access outside the class, so why to access it through a variable name or via the name mangling? If it is a private, maybe you can try to use a get name, and then you will be able to get the name. Yeah, get name, because eventually get name is trying to call. So we are trying to basically hide the implementation. We are trying to basically say that, no, I don't want to show you. I don't want to expose this. Yeah. So maybe you can try to call it in this way. But yeah, you can even try to call it just by appending the underscore class name. That is also possible. But you should know always that it's a private variable. So treat it in that way with giving a due respect. Because this is what Python thinks. Python thinks that you are mature enough to handle it. So with that, guys, thank you so much, everyone. Take care, and see you again once again in my next lecture with a new topic. So take care till then. Okay, so in this lecture, guys, I'm going to talk about abstraction inside a OOPS concept. So let's try to understand what is abstraction, how we can try to do a implementation of the abstraction in a practical manner. So here is my screen, and first of all, what is abstraction? So abstraction is nothing but kind of creating a skeleton which will be eventually implemented by someone else, maybe in a later stage. That is something called as abstraction. Now, to achieve abstraction, you have to call ABC class. ABC means abstract base class. So from ABC, you have to import first of all capital ABC and abstract method. Just try to import this one. So without this, you will not be able to create an abstract class. Now, how I can create an abstract class and what is the meaning of abstract class? Let's try to understand in a practical way. So class mentor, let's suppose I have created, and here I have written ABC, right? ABC I have written, let's suppose. Now by writing this, when I'm inheriting this ABC, which is abstract base class, the meaning is abstract base class, by the way, for this one. So here, right, so here it is trying to create this class as a base class. Base class means, let's suppose I'm a manager. Now I have to create hundreds of function. I have to write hundreds of function, and I would like to distribute all of these things among like many of my employees, right? But as a manager, so I have to, or as a lead, I have to create a complete skeleton that, okay, this method should be implemented, that method should be implemented, this should be done, that should be done. So what I will do is that I will try to create the abstract base class inside a Python. So in this way, and then I can try to define a method. Just declare the method, right? So for example, so def teach, teach method, and then I'm going to write it self, and here, so I'm not going to give any kind of a definition, and to make this method as an abstract method, so I'm going to decorate it as abstract method. So now I have not given an implementation. Anyone and everyone who is going to call this class, they will do the implementation. I'm not going to do the implementation. So likewise, I can try to create as many method as possible. So def maybe a mentor method someone is going to write. I don't know who, but yeah, someone is going to write. I'm leaving it as it is. So here I'm just trying to create the skeleton of the entire class. So here maybe COURSE course, someone will come and someone will try to implement it. Let me make it as a abstract method. Yeah. So let me make it as a abstract method over here. So in this way, I have made everything as an abstract method. Everything as an abstract method I have created. Simple, right? So everything as an abstract method I have created over here. Now, so now if anyone is going to create a class, so for example, a class Euron mentor, and if I'm going to call a mentor class, which is nothing but abstract base class, so here everything will be available, right? Everything means all of this function will be available. So anyone can call this function and anyone can try to do the implementation of this function. For example, def teach, and here, so this will return teaching. Yeah. So here anyone can call and anyone can give a definition. So anyone's maybe some different class can try to call this one, and then they will be able to give a definition of this according to themselves. Now the most important part is, let's suppose if I'm going to create a object of this Euron mentor, right? I will be able to call Euron mentor dot teach. Fine, Euron mentor dot teach. I will be able to call it. Can't instance the abstract class enumerator with the abstract method. Sorry. Abstract method, course and mentor. Yeah, so mentor. Okay, so yeah, mentor I have given, and let me give a definition of mentor. So definition of mentor is, this will give a detail about mentor, and then def course. So this will give a detail about course. Okay. Now, so here I have just done the implementation of all this function, which was defined as a abstract function. Yeah, abstract method. So whatever was defined as a abstract method, I'm able to define it in my own way, or any class who is calling a mentor, so they can try to define it in their own way. As simple as that. Okay, fine. Now, so Euron.teach, so I'm able to invoke this one. So this is nothing but this is my child class, or you can say this Euron mentor class object. Now, the question is that will I be able to create an object of this mentor class, the abstract base class? Let's do that, right? So m is equals to mentor. This is the object. Now it is telling me that can't instantiate abstract class mentor with abstract method course mentor ending. So you will not be able to create, you will never be able to create any object or any instance or any variable. Yeah, remember always that you will never be able to create any variable of the abstract base class. This is my mentor, is my abstract base class, right? So directly you will never be able to create any instance, any object or any variable of this class. Whoever is trying to inherit it and they are trying to do the implementation, only for those class you will be able to create an object and you will be able to invoke it. And I believe that makes sense, right? I believe that makes sense properly, right, for all of us. Okay, now, so when you are trying to create an abstract base class, so not just this, you can try to create not just abstract method, you can try to create some regular method as well. That's completely fine. So let's suppose I'm creating a welcome method, self, yeah, self, and here I'm trying to maybe return, return. So return what? Welcome to Euron. So inside this abstract base class, these three methods are basically a abstract method, and this is the regular method, right? This is not abstract method I have written. Like I said, you will never be able to create an object of abstract class. Simply means and let's do that in this way. Mentor dot welcome. Yeah. So you will never be able to call this one even directly. But let's suppose I'm trying to create some of the class implementation, so which is trying to inherit the abstract class. Now I will be able to call it with the help of its object. Let's suppose Euron mentor. So Euron mentor, right? So EU dot. Now if I'm going to call welcome, I will be able to call welcome. Although welcome is not a part of this one, welcome is coming from this mentor. But same welcome method, I will not be able to access it by creating an object of my abstract class, because technically it will not even allow you to create an object. As simple as that. Yeah. So if the class is abstract, you will never be able to create an object in any kind of a situation at all. So with that, guys, thank you so much. Take care, and see you again in my next lecture, by the way. Yeah. Okay, so it's a small topic, guys, which I would like to discuss with all of you. There is something called as duck typing. It's a very easy and basic topic. I believe we all are aware about it. But yeah, so it's a same like name. If you will go after the name, so maybe you will not be able to understand. But I believe by default, so we all understand this concept. So I don't think that anyone will face any kind of a problem with respect to this duck typing. So I'm going to show you an example, and with the help of example, so I'll try to show you like a complete like what is actually called as duck typing. So here, let's suppose I'm going to create a class called as course, right? And I'm going to write def init, init underscore underscore. And here, so it is going to take self, and then it is going to take basically a topics. Okay, fine. And self dot topics, topics is equals to topics. So this is something which I have defined. And then here, so I'm going to call my special method called as length. So we have already discussed about this special method called as length. So it will always try to return the length of the object. Yeah, this is what it does. So return what? So return basically a length of what? So length of self dot topics. Return length of self dot topics. Okay. Now if I'm going to create an object of this course, see, so object of this course, if I'm going to create, so obviously I have to pass a topic. So let's suppose if I'm going to pass topic is equal to SUDH, and if I'm going to call length, it is going to give me 4. Now you don't have to, so I think we all are aware about this one, right? So there is no surprise for us. Yeah. What I'm trying to teach you over here is that I'm trying to pass a string. It is able to do the calculation. Now I will try to pass, let's suppose C1, and I will try to pass not a string over here, but I'll try to pass list maybe, yeah, list, and then length if I'm going to call C1. So even with list, it is working, right? This length function is working. Yeah, it's working. Now if I'm going to pass maybe a tuple over here, so not just list, maybe a tuple if I'm going to pass. Yeah, maybe just a tuple if I'm going to pass. And then if I'm going to check a length, so length of basically this object C1, it's working. So now what I'm trying to prove over here is that you have defined a length, and doesn't matter what kind of a data you are going to pass, it is going to work. And this is called as Ducktyping. Ducktyping means what? So something which is irrespective of what you are going to do, unless and until you are not doing something wrong, it is working. That's something called as Ducktyping. So this length is working for all kind of a object which I'm trying to pass, all kind of a data which I'm trying to pass. So this entire concept is called as Ducktyping. So here this like a length is behaving like a duck, right? It's trying to behave like a duck, sound like a duck basically, and act like a duck over here. And from where, so we are able to define Ducktyping. So not a big concept, very, very small concept. I believe that you all should know. So yeah, with that, thank you so much everyone. Take care, and please do the assignment. I have attached a very good amount of assignment with this entire OOPS concept. So try to do that assignment. You all are going to enjoy it. You all are going to love it at the end of the day. So with that, thank you so much. Take care, and see you again in my next lecture, guys.